Hi everyone, and welcome to Sweet Math. Today we have another fun geometry challenge. We have a large square divided into 4 equal smaller squares by these 2 lines. A circle touches the midpoint of the left side of the square. This segment measures 8 units, and this segment measures 12 units. Can you find the value of x, the side length of the large square? Before we begin the solution, pause the video, try solving it on your own, and leave your answer in the comments. Now, let's solve it. Since this is a square, all 4 sides have the same length, so every side is x. Also, because the circle touches the square exactly at the midpoint of its left side, this entire distance is half the side length of the square. Next, let's mark the center of the circle and draw a line from the center to this intersection point. What happens? We get a right triangle. Perfect. Now let's identify the 3 sides of this triangle. Let's start with the hypotenuse. It's the radius of the circle because it connects the center of the circle to a point on its circumference. So its length is r. Now, what about the vertical leg? Notice that this entire distance is half of x. The upper part measures 8, so the remaining vertical side is x over 2 minus 8. Finally, let's find the horizontal leg. Notice that this entire distance is also half of x. From the center of the circle to the point where the circle touches the square is the radius, which is r. So the remaining horizontal side is x over 2 minus r. Great! Now that we know all 3 sides of the right triangle, we can apply the Pythagorean theorem. According to the Pythagorean theorem, the square of the hypotenuse equals the sum of the squares of the other 2 sides. So we can write r squared equals the quantity x over 2 minus 8 squared plus the quantity x over 2 minus r squared. At this point, we have one equation with 2 unknowns. So we need one more equation. How can we find it? Take a closer look. This segment is r. This segment is also r, because it connects the center of the circle to another point on the circle. And this segment measures 12. Together, these 3 segments make up the entire side length of the large square. So we can write x equals r plus 12. Or simply, x equals 2 times r plus 12. Now, let's substitute x equals 2 times r plus 12 into the first equation. This gives us the following equation. Next, let's separate the fraction to simplify the expression. Then, divide both terms by 2 and we get this equation. Now let's simplify the expressions inside the parentheses. In the first parenthesis, r plus 6 minus 8 becomes r minus 2. In the second parenthesis, positive r and negative r cancel each other out, leaving us with 6. Now let's square both expressions. We get r squared equals the quantity r minus 2 all squared plus 6 squared. Expanding the squares gives r squared equals r squared minus 4 times r plus 4 plus 36. The r squared terms cancel from both sides. So we're left with 4 times r equals 40. Dividing both sides by 4, we get r equals 10. But that's not what the problem is asking for. We need to find x, the side length of the large square. Now substitute r equals 10 into the equation x equals 2 times r plus 12. This gives us x equals 2 times 10 plus 12. Therefore, x equals 32. I hope you enjoyed this geometry challenge. If you found another way to solve it, let me know in the comments. And if you enjoy geometry challenges like this, don't forget to subscribe to Sweet Math. Thanks for solving it with me, and I'll see you in the next challenge.